Good evening, everybody, and thank you for joining a Daily Maverick special webinar this evening. We've called it a special webinar because it's special, and it's special because it's unusual, because for the first time we have a panelist who is under 40, a young person, to speak to issues of COVID-19, but also special because we're pleased to be hosting a discussion on an issue about COVID-19 that hasn't been sufficiently traversed in public, which is the question of COVID-19 and children, and COVID-19 and children and vaccinations in particular. So we're very, very grateful that you saw fit to join us. For the purposes of the discussion, as I've already said, we have two panelists, and I'll introduce them very briefly. First of all, most importantly, I want to welcome Alex White. Good evening, Alex.
Hi, Mark.
Thank you for being with us. Alex will say a little bit more about himself later, but he's an 18-year-old student doing matric in his matric year in Cape Town, but he's also a young journalist for RX Radio at the Red Cross Hospital in Cape Town, and he runs his own program at that station. Alex is with us tonight because he's been part of a team that has been canvassing young people for their questions and their concerns and their issues around COVID-19. And they've collected a big basket of questions. And with that big basket of questions, we're fortunate that we have one of South Africa's foremost experts in COVID-19 and infectious diseases generally, which is Professor Salim Abdool-Karim. Good evening, Prof.
Very good evening. Good evening to Alex and to Mark.
Thanks. Slim, I think, is familiar to these webinars and familiar, I'm sure, to all of you. I'm not going to give an exhaustive bio, except to say that he was formerly the co-chair of the Ministerial Advisory Committee on COVID-19. He has decades and decades of experience in HIV, in tuberculosis, now in COVID-19. He's the executive director and founder of an organization at the University of KwaZulu-Natal called Caprisa. So, Slim, we're very fortunate and grateful that you've made yourself available to try to answer young people's questions. So we're going to jump straight into the conversation, but let me just set a little bit of a foundation before I ask Alex to speak by saying that from the beginning of the COVID-19 pandemic, February or March of 2020, we understood pretty quickly that COVID-19, the disease, that this virus would have its worst impact on older people, and particularly people with comorbidities. But in our measures to contain the epidemic, we found that it's young people in particular who often have paid a great price in terms of not being able to go to school, in terms of loss of parents, loss of friends, loss of family, etc., etc. And we also know that COVID-19 affects young people, that young people are infected with COVID-19, that very occasionally young people get sick because of COVID-19. And yet, despite all of this, I think, and I can't speak, Alex, you will speak for young people, but despite all of this, there's a feeling that young people have been left out of the conversation, that there hasn't been enough public education, health education that speaks to young people, that identifies what young people's questions are and what their concerns are. So I hope that today we're going to be able to start to rectify this and swing the pendulum in a more equal direction, because COVID-19, of course, affects us all. So, Alex, let's start with you. I'd be very grateful if you would just begin by telling us a little bit about RX Radio, your role at RX Radio, and what the issues are that you and your peers are concerned about? Thank you, Alex.
Thanks, Mark. So I'm Alex White. I'm 18 years old and an RX radio reporter, like Mark was saying. I've also got a passion for media. And then I host the RX Top 10, which is a countdown show on Saturdays where we look back and count down the top 10 biggest tracks of the week. And then I was part of RX Radio, I have been part of RX Radio since 2015 when I met Dr. Gabriele Goetti, who was the founding kind of brain behind RX Radio, former station manager. In 2017, RX Radio went live. And today we broadcast 24/7 in Afrikaans, English, and isiXhosa at 3 hospitals. That's Red Cross War Memorial Children's Hospital, Paarl Hospital, and Brooklyn Chest Hospital. And obviously the goal is for RX Radio to spread into all children's wards across South Africa. So RX Radio, like I said, it's a radio station for young people, for children. It's by and for children. And the whole idea behind RX Radio is to give a voice to the youth, give a voice to children. In that way, it functions as a children's rights and advocacy platform, and it adds to the holistic care of children when they're in hospital by contributing to the healing process. And it serves as a platform between the patients, the parents, and the healthcare workers, because so often children are left out of decisions that affect them when they're in hospital. And so it's a platform for them to ask questions, to have discussions, and to know more about what it is that they're going through when they're in hospital, and to really make their time as well in hospital that much more bearable. So patients host shows, they're on air, and the patients listen to the shows as well. So it really adds to the experience of the hospital to be a bit more positive for them while they're there. But it's a lot more than just providing health information, which we do obviously a lot of, interviewing doctors, nurses, PSAs, those are public service announcements. So we do a lot of health-based stuff. All the shows will have health-oriented interviews at one point or another, but it also just provides a platform for children and youth to talk about things that affect them, that otherwise aren't discussed and aren't put out there, and also so they can just have fun, whether it's with music, talking about movies, different topics, food, books, all sorts of things like that. So it really is a platform, a media platform for young people, for children, and by children. And then to tie it into COVID-19, so obviously being a non-profit organization, a health-oriented one, last year when COVID-19 broke out in March, immediately we weren't able to broadcast anymore from our incredible studios at the Red Cross War Memorial Children's Hospital here in Cape Town. So we took things online, and we got RX Radio reporters to record public service announcements. So that's information about what COVID-19 is, the different things that you can do to prevent infection. And these, again, were recorded in English, Afrikaans, and isiXhosa by our different RX Radio young reporters. And through WhatsApp, they were sent in and played out through the various shows. I was able to host a show from home during this time, and we kind of focused it quite heavily on COVID-19, chatting to people about how COVID-19 was affecting them, different performers, musicians, artists, etc., chatting to them, chatting to doctors, nurses, and people all around the world about how COVID-19 was affecting them. And we got reporters from all over to contribute to that show as well. And then kind of the last thing that I'll touch on is that we were involved with Children's Voices on COVID-19, which was where we got reporters as well as just children from all across South Africa to send in their experiences with COVID-19, whether it's how it affected them, their family, their schooling, their education, what they thought about it. And then we also got in a couple parents and healthcare workers as well. But the main focus was on children, getting their voices heard, because we knew from the start that COVID-19 was something that affected adults more. So children were kind of left out of that conversation, and we were adding them back into it, saying, because we still want children to understand what is happening and how this is affecting them. So we got children from all across South Africa, because as we know, South Africa is a very diverse country, so it's affecting people in different ways. And they also got young children from all around the world, China, the United Kingdom, and Argentina. And that project, Children's Voices on COVID-19, was lucky enough to be recognized by the World Health Organization, winning their Reboot Health and Wellbeing Innovation Challenge last year, and other accolades that RX Radio has won. We've been nominated for and won several SA Radio Awards, and were visited also by President Cyril Ramaphosa on Mandela Day last year. So that's a little bit about RX Radio and what we've been doing in terms of COVID-19. Up to date, we've trained over 100 reporters between the age of 4 and 18, and there's more information at rxradio.co.za. Thanks, Mark.
Thanks. Reporters between the ages of 4 and 18, that's wonderful. And your interventions around COVID-19 sound very important as well. Well, before we go to your specific questions, Alex, I want to turn over to Prof. Abdool-Karim. Professor Abdool-Karim, what do you think are the headline questions, if you like, the key things that should be understood about children's susceptibility to this particular virus, the vulnerability to disease? What would you say to people this evening are the critical issues to understand?
Yes, thanks very much, Mark. It's a great pleasure to be with you here this evening, and it's wonderful to hear of Alex's good work at Red Cross Radio. So I thought I'll just touch on 5 quick things, if I might. The first is, it's quite important to remember, because there's confusion out there sometimes, that children can get infected with SARS-CoV-2 virus. That children, just like adults, have a particular receptor, now a particular cell that has a part of the cell where the virus can enter. It's called, I'll just give you the name so you know, it's called ACE2. It's a long name, but those cells with ACE2 are present in the nose and the back of the throat and the lungs of young children just as much as they are present in adults. So yes, children do get infected with SARS-CoV-2. That's the first point. The second is, fortunately, children rarely get the clinical disease called COVID-19. So they get infected, but they very seldom get clinically ill. Now, that's actually quite common in many diseases. If you take influenza, for example, children get influenza very mildly, whereas it's much more severe in people over the age of 60. So COVID-19 is a very similar problem. It's the same virus, causes infection across all age groups, but when you're above 60, you have a much higher chance of getting clinically ill, requiring hospitalization, and so on. So children get very little clinical disease and very rarely will need hospitalization, and even more rarely will have a risk of dying. It's very rare. The third point is that when we look at the way in which this virus spreads, children, because they can get infected, can spread the disease to others. But they spread it much less so. And there are now at least 3 good studies, what we call secondary contact studies. So these are secondary attack rates. They are looking at, from a person who is infected, what's the risk of others getting the virus? And what has been found is that children get it less from an adult who is infected in the home, and children spread it less when they get infected. They do spread it, but it's just less so. So the risk of transmission is slightly less. The fourth is that what we know about the prevention of SARS-CoV-2 infection or COVID-19 that applies in adults, all of it applies in children. The same benefits that adults get from social distancing, from mask wearing, are the same benefits that children also gain. I know some people tell me, but my child is so short, he's not going to breathe in the virus, and is not going to cough up the virus that other adults are going to breathe in. Well, it doesn't quite work like that. I mean, that's why the risk is lower, but it still transmits, and the public health prevention mechanisms are equally effective. And my fifth point is that we are hoping that we will see results on vaccine trials in children, hopefully by the end of this year. So right now, the evidence we have for the safety and the efficacy of vaccines is limited to people above the age of 18. So that's adults. There is one vaccine that has been tested already in children, one class of vaccines called mRNA, and that's been studied in children from age 12 to 18 and found to be safe and effective. So we don't know yet about some of the other classes of vaccines in that group, but at least the Pfizer vaccine that's available in this country has been shown to be safe and effective in 12 to 18. But we don't yet know whether these vaccines are safe or effective in those below 12. So I hope those just give you a quick 5 points to help you understand COVID-19 in children.
Very clear, very important 5 points. Thanks, Prof. Abdool-Karim. Let's get one thing clear, because I've seen these questions from a few people already. Alex and Slim, who are we talking about when we're talking about children? Are we talking about all people up to the age of 18? What's your definition? And does it matter whether a child is, for example, 5 or 6, i.e. an infant, versus a child who is 16 or 17, an adolescent, a young man or woman? First of all, Alex, what's a child as far as you're concerned? And then Slim, if you can talk about risk and disease presentation across an age spectrum, just very quickly.
So at RX Radio, when we're talking about children, we generally incorporate everyone up to 18 because that's the children that can be involved with RX Radio, but we tend to also call them young reporters. And like I said, we train people, young reporters from the age of 4 up to 18. But yeah, there are definitely differences within that range. But one thing remains is that up to about 18, when you are regarded as children by the healthcare system, that's the period in which we find there needs to be more engagement with young people about the issues that concern them. So that's one thing that's consistent right across that age range. So yeah, that's what I would say.
Thanks, Alex. Slim?
Just to say that there's a legal definition of child in the Child Act. But for practical purposes, 18 is a good cutoff for a range of different reasons, one of which is that most children 18 and lower are in schools and require some kind of parental consent or assent for many things that they want to participate in. So it's just a convenient sort of cutoff to use 18. Even though there are different cutoffs for different kinds of activities and medical care that children at different ages can agree to. So I think 18 is practical. From the point of view of COVID-19, age 6 is another cutoff that's useful to work with, because from 6 and above, masks are thought to be helpful. Below 6, masks are not an issue. And, if the child is not able to wear a mask, we just let anyone wear a mask, but children below 6 don't necessarily need to wear masks. It doesn't provide the same degree of benefit as it does for those over age 6, and it's more difficult for younger children to wear masks. So that's the only distinction. In terms of illness, in terms of the clinical presentations, there are some slight differences. And something that we're going to get to later, I'm sure, is the concern we all have now that even though children do not get the severe forms of COVID-19, children do get a particular form of COVID-19 called long COVID. Long COVID is not even a clear entity. It doesn't have a clear definition, but basically it refers to a state where you feel, they call it, brain fog. You feel a bit muzzy and you can't concentrate, you can't read, and it lasts for more than about 3 months after your diagnosis. So that is now being described across the world as quite a common problem in children. It's quite common in adults. It accounts for about 10 to 15% of individuals who've had COVID-19 get long COVID. So I think that that's among the things we're beginning to better understand. And so long COVID seems to occur in the adolescent part of in the teen years more than in the younger ones.
Thanks, Salim. Look, the purpose of this evening is particularly to have young people put questions to you. So I'm going to hand over to the first set of questions to Alex in just a second, but I just want to assure people who are with us in the audience tonight that I'm watching what's coming up on the chat. There are many, many questions, and we won't get to them all tonight, but we might decide to have another session. But I'm noting questions about children's anxiety, about death and dying of family members. I'm noting questions about infection in utero, which perhaps Slim will come back to a little bit later on. I'm noting questions about rising rates of infection amongst children in parts of the world like the United States, practical questions about how do you manage COVID in boarding schools. There's a lot of very relevant and very valid questions. We'll do our best to make sure that we cover all of those questions, but I'd like Alex, who's diligently collected young people's questions, to just raise an initial set of issues with Professor Abdool-Karim.
Cool, thanks, Mark. Yeah, we've got quite a few questions that were raised. They were put together by RX Radio's young reporters. Like I said, there are over 100 young reporters that have been trained. So yeah, what was evident is that there are a lot of things that our young reporters want to know about COVID-19, and particularly about the vaccine, since it is something new for them at the moment, and it's the relative focus right now. And so I think, Prof, to start with that, because I think in your introduction you went over COVID-19 and its impacts on children quite extensively, also mentioning long COVID. So now to go a bit into the vaccines, I think a question raised by all the young reporters was just, what is a vaccine? Why do they help? And then what is this concept of herd immunity?
Right, so let me try and give you a very simple explanation. So viruses have parts of the outer covering, what we sometimes call the envelope, that have proteins on them that the body can recognize and mount an immune response against those proteins. Now, that's not unique to SARS-CoV-2. It occurs with any other virus, polio or measles, or, any of these other viruses. The body mounts a response. Now, the problem is that when the virus enters the body takes time to mount that response. It takes about 2 to 3 weeks to mount an antibody response, and slightly longer to mount what is called a T cell response, a killer cell response. So those are the two key parts of our immune system. Because it takes that long, it's not really there to protect you. So what we do is we give you a vaccine. We give you a vaccine where we take the part of the virus on that envelope, and we either take a whole virus, just kill it, and so it's got the envelope, or we just give you the envelope itself. And we give that to you in a way that it's harmless. So it can't cause any illness, but it gives your body a trial run, and it makes your body develop that same immune response as if you were encountering the real virus. And so what happens is that once you've had that dummy run, right, a run against just the protein, not the real virus, not a live real virus, your body develops an immune response, and importantly, you develop something called memory. There are special cells called memory cells And they remember, and they'll remember this virus, this protein that it's responded to. They will remember it till you die. Right? So these memory cells are very important. So now that you've got these memory cells, if you get a real virus coming to your throat or mouth, in the case of SARS-CoV-2, you already know this enemy. You know this enemy. You're ready to take it on. And so you don't need time. You can just respond. Your body is ready to respond. And in fact, already has antibodies tackling the virus right from the time it enters the nose or the throat. So it gives your body a head start. And it's now had a practice run. It knows what to do. It's all ready to go. So that's what a vaccine does. Now, what we want in a vaccine is we'd like it to kill the virus before it causes an infection. But there are very few vaccines that can do that. Most vaccines, they prepare your immune response. So when you get the real infection, you do get a small infection, right? And it's when that infection occurs, your body's memory kicks in and generates a whole lot of new antibodies. So you will get but so some people ask me, but I've been vaccinated. Why am I getting infected with SARS-CoV-2? Why am I getting infected with COVID? Well, you do get infected. You just won't get clinically ill to the same extent, and you will very rarely get so severely ill that you need hospitalization because your body's immune system was ready. So that's what these vaccines do. Now, when we vaccinate enough people within a community, then the virus, even if it starts spreading, will get to people who are already protected. And so herd immunity is a concept. And it's borrowed from agriculture, but it's a concept that if you vaccinate, not everybody, but you vaccinate a large enough number of people, then everybody is protected. And you will still see outbreaks. For example, with measles, we have quite high levels of immunity against measles, close to herd immunity. We still get outbreaks of measles because there are pockets that are not vaccinated. So you do, and you will see that. But mostly transmission of the virus is at a very low level, and it can't really cause big disruptions. It just causes small outbreaks. So that's what we try to achieve in herd immunity. And that's quite important because remember, vaccines have two things. They have individual benefit. They benefit the person taking the vaccine. And then they have a community benefit or population benefit, where you taking a vaccine protects everybody in the community as well.
Thank you. Many listeners are saying how clear and simply you're presenting it, Prof. That's great. Alex, any further questions arising from what Professor Abdool-Karim has just said?
Yeah, so Professor, I think also that was very clear, nice and easy. One of the things you did mention earlier on is that there is a vaccine that has been tested on children, or you said a class of vaccine that's being tested on children. So what are the differences between the vaccines that are in existence? Can you tell us a little bit more about that? That was a question raised by Connor from RX Radio.
Sure. There are 4 classes of vaccines right now for SARS-CoV-2. The oldest type of vaccine, which is tried and trusted, is what is called a whole inactivated virus. So, for example, you can take a virus, let's say measles for argument's sake. We take measles virus and we grow it in tissue culture in the laboratory. We purify the virus from the culture, and then we apply heat to it, just instantaneous heat. And so what it does, it kills the virus. The virus is dead. And then we put it in a bottle, We give it to you, dry it up in a syringe, we inject it into you. We're giving you dead measles, right? Now, it can't cause measles. You can't get measles, but your body mounts an immune response to it. So that's what is called whole inactivated vaccine. The second is called protein subunit vaccine. And there are many such vaccines. Hepatitis B is a good example of that, where you don't give the whole virus, you just give the surface part of the virus. That's really important for the immune response, because the immune response is not going to deal with the rest of the virus. It's really interested in that surface part. So you can just take that protein subunit. So that's the second class of vaccines. And I can give you examples. So a whole inactivated vaccine is like Sinopharm, Sinovac. Those are whole inactivated. Protein subunit is like the Novavax vaccine. The third class of vaccines are called viral vectors. They sometimes refer to as live viral vectors, but they're just viral vectors. We use a virus that doesn't cause any particular disease. It's a very mild, bit of cold, if at most, called an adenovirus. And we use a Trojan horse approach. We basically put into this adenovirus, we put in the RNA of Covid-19, of the SARS-CoV-2 virus. And so what the adeno does is that it presents the proteins from SARS-CoV-2 to the antigen processing cells, so what we call APCs. But basically, it just makes the immune response better. And then so those kinds of vaccines is like the Johnson & Johnson vaccine, the AstraZeneca vaccine, the Sputnik vaccine. And then you've got the mRNA vaccines. Now, mRNA, or messenger RNA, was discovered by a very famous scientist called Tom Cech. And Tom, when he made this discovery, described how messenger RNA actually works. And messenger RNA is in all our cells. So what this is, it's just giving messenger RNA into your muscle. It goes into your cells, it redirects the cell machinery to make the proteins that are on the surface of the virus, and then it causes quite a substantial immune response. So that's mRNA vaccines. The one made by Pfizer BioNTech is an example. The one made by Moderna is an example. So in our country, we are using two classes of vaccines. We are using the Pfizer vaccine, which is messenger RNA, or to call it short, mRNA, and we use Johnson & Johnson vaccine, which is a viral vector vaccine. So those are the two we use in this country.
Thanks, Slim. Quite a number of people have asked whether we're recording this. Yes, we are recording it, and will be available on the Daily Maverick website tomorrow and for all time. So you can use it as a resource. I'm overwhelmed by the number of questions, and they're all very, very sensible and important questions that are being asked in relation to this discussion. Alex, before I go back to your questions, I just throw a few quickly at Slim from the audience for quick answers, if possible. If you vaccinate young adults, does it cause infertility in men or women? That's one question. Another question is, should children with comorbidities be prioritized for vaccination when vaccination starts? Another question was, should you have your ordinary flu vaccine this year if you're also going to be vaccinated for COVID-19? And just a fourth question, if you've had COVID-19, given that creates immunity, do you still need to bother with a vaccine? I have to ask you for rapid fire answers, Slim, because I know that Alex has still got plenty in his basket, but let me help some of the people who are asking valid questions.
Okay, I'll try and be quick. I'm just sorry. I like teaching and making sure everybody understands.
No, I'm not complaining. You're doing a fantastic job. It's not a criticism for a second.
Right. So firstly, no, all of the vaccines in all four classes do not impact fertility. That's known, it's a fact. How do we know that? Because it's a requirement of licensure, it's a requirement, it's a regulatory requirement. You have to do something called reproductive toxicity, and that is a study of whether the vaccine impacts fertility in any way. So all of these vaccines are safe as far as reproduction is concerned. They don't impact fertility. The second question, now you lost I couldn't remember them in rapid fire.
Children and with comorbidities.
So children with comorbidities are thought to have a slightly higher risk of COVID. But overall, children, including children with comorbidities, have a very low risk of severe COVID. So there's no urgent need to vaccinate children with comorbidities. They will come in line anyway as we come down the age groups. I think the other issue is that we can't vaccinate children below age 12 anyway, because we don't have evidence of safety anyway. So we are now, within the next 2-3 weeks, we're going to be going down to age 18 anyway. So you will be able to get vaccinated within the next 3 weeks or so. So there's no need to prioritize, given that it's coming anyway, down to age 18. The third issue, I think, was about flu vaccines.
That's right.
The answer to that is yes, you should take a flu vaccine, particularly if you're elderly. Right? Children should also take it if they are at particular risk. But we advise certainly the elderly to take it, and anybody who can afford it should take the flu vaccine. The flu vaccine is different from the SARS-CoV-2 vaccine. The COVID vaccines are very different. These are two different classes of viruses. They don't have any antigens in common. You have to take the two vaccines. But we recommend that you keep a 14-day gap between the two. So when you take your flu vaccine, don't take a COVID vaccine within the first 14 days. It's a small reason. It's not particularly important. I won't go into that, given we're just trying quick answers here. And finally, the question was asked about, should you take a vaccine if you've actually had COVID, natural infection? Now, the answer to that question, I could talk for the next 10 minutes on it, but I'll just give you the short answer. The short answer is yes, take the vaccine. And the thing about it, it's called, in medical terms, it's got a nice name. It's called hybrid immunity. Now, don't think about it, about immunity that works both on petrol and on batteries, like your hybrid cars. It's not like that. Hybrid immunity is where you've had natural immunity and you superimpose on that vaccine immunity. When you give a vaccine, any vaccine, doesn't matter which one, any vaccine, to somebody who's had past infection, they get an enormous response. They have really amazing immunity. And giving them a second dose of vaccine doesn't help them that much, actually. So just even if they take a single dose, they do quite well. Even though we recommend that everybody should just take the 2 doses of Pfizer or the single dose of Johnson & Johnson, if you've had past infection, you get amazing immunity with that. It's called hybrid immunity.
Thank you, Salim. Now I'm going back to Alex. And Alex, I'm going to, as you ask more questions to Salim, I'm going to ask you one question, because I think it was, and if you don't have the answer to it, I think Salim answered it already, but I can't avoid it because it comes from 9-year-old Cameron in KZN. And if there's a 9-year-old submitting a question, then I have to answer it, or have to have it answered. Would like to know, do children spread COVID faster than adults? Alex, if you feel able to answer that based on what we've learned this evening, do. Otherwise, Slim will pick it up as part of your next round of questions.
Well, I'll have an attempt. I think from what I was understanding from what Prof was saying earlier, is that it appears that children spread COVID less than adults, is what we've been picking up, especially the younger children. So I don't know if that affects the speed, but definitely how much it spreads. Yeah.
I think you passed.
Okay, cool. And then I think we'll go on to some more of the questions we've got in the bank here. And one of the concerns that was raised, especially by the young reporters, considering many of them are children who have chronic conditions at Red Cross, and they were talking about when people get the vaccine, some of them fear that they might get quite sick, or that you could perhaps die, things like that. Those were concerns that they were raising. So what are the risks of that? And then on the other hand of that, there was the idea of what is vaccine efficacy and how are they measuring how successful vaccines are? Because they also recognized, like Prof pointed out, that it doesn't stop you from getting infected. It just stops you from getting quite sick. Yeah.
Okay, so let's deal with the first issue regarding how safe are these vaccines. They are incredibly safe. I mean, we don't actually have any other vaccine that we have given, to 4 billion people in a matter of a few months. So given that so many people have had this vaccine, we have incredible safety information, and these vaccines are pretty safe. Now, some of these vaccines have some rare side effects. Now, let me just say, there is no medication I know of that has 0 side effects. That doesn't exist. So every medicine, even if you're to take a normal painkiller or anything, any medicine will have some side effects. And they're usually mild, and they're usually easily tolerable. So in the SARS-CoV-2 vaccine, when you take the vaccine, you do get a mild flu-like illness. So in other words, you take a vaccine, your arm pains, you get a bit of a fever, feel a bit muzzy. Just sleep it off. Take a Panado or some painkiller, an anti-inflammatory like ibuprofen, and you'll do pretty well. They generally last for 24 to 48 hours. By day 3, it's all gone. And that's just temporary. It actually is a sign that your body is responding. It's a sign of the inflammatory response. So it's a good thing when you get that mild illness. And it's nothing to be concerned about. It's just part of the vaccination process. However, 1 or 2 vaccines, and this applies particularly to viral vectors, it seems that in about 1 in a million vaccines, there occurs some clotting abnormality. And there's been about 30, 40 cases reported in the world that we know about that have been well described, and they're accumulating cases of them. So it's gone even higher now. But it's very rare. We don't really understand it because it's unusual. I won't go into the details of it. And at this point, there's no way of predicting who's going to get those severe side effects. Fortunately, very few of people who have those side effects die, and most just recover over time. So it looks like this severe side effect that does occur, it occurs very rarely. And the risk of it is so much smaller than all the risks associated with COVID-19 that we say the risks and benefit lie on the side of vaccine. So it should be 0 reason why you would be concerned about it when you go and take your vaccine. Your chance of getting it, 1 in a million. You'll take that. I mean, people would take better odds than that on many other things. So it's a very low risk. Now, to answer your second part of your question, I'm trying to remember what that was. What was the second part of your question, Alex?
Yeah, the second part was about efficacy and what that as a term means. Yeah.
Okay. So one of the problems was when these vaccine trials started, they started in the second quarter of last year, and there was no rules about what is the outcome that they should all measure. So the vaccine trials measured outcomes or efficacy slightly differently. So you'll hear people say, oh, I'm comparing efficacy of this vaccine or that vaccine. but you can't because they measure different things. So it's not easy to just compare them. But we measure efficacy really in two key ways. Did you get infected at all? And usually that involves both clinical and asymptomatic infection. So that's a measure of whether you became infected using antibody tests. We can measure for antibodies that are not included in the vaccine, and that means you become naturally infected even though you've been vaccinated. So we can measure that. So that's one measure. Not many vaccines have measured that. The second measure, did you have any clinical illness of COVID-19? And that's what most of the vaccines have measured. They have measured, do you get clinically ill? And that's, one or two symptoms. You got to have like fever, sore throat, things like that. The third measure that's become important is to measure severe illness. And there are gradations of that. There's a scoring system we have. The FDA recommends we score things according to mild, moderate, and severe. And with severe, we also measure hospitalization. And with hospitalization, we also measure the next step, which is death. So it's across this entire spectrum that we can measure vaccine efficacy. For simplicity, for this audience, when they see a number and somebody says, oh, the vaccine efficacy is 82%, they're really mostly talking about it's 82% effective in preventing clinical illness.
Thanks. Very clear and comprehensive again, Salim. Time is running against us. Alex, you're going to have to pick your kind of priority questions because we've only got 13 minutes left. While you're thinking about your priority questions, Salim, just because this keeps on coming up on the questions, again, I want almost yes or no answers if possible. Can you transmit COVID through breastfeeding? Do you transmit COVID in utero?
No.
No. So Salim says no and no to both of those. Thanks. We've got those out of the way. And then because we're hearing children's voices, just to say thank you to Anna, 8-year-old Anna, who said, is COVID-19 worse than the Spanish flu? And I know that probably doesn't have a quick answer. I don't know. Perhaps just put that in your back pocket, Professor.
No, I can answer that.
We come to the end.
It's been well studied. No, COVID is not as bad as the Spanish flu. And by the way, the Spanish flu has little to do with Spain. It originated in the US.
Exactly. Thank you. Alex, back to you.
Yeah, cool. Thanks. I think the one question here that's come up, it was raised by a couple RX Radio reporters. I've also seen some repetition of it in the chat, and it's along the lines of schooling, particularly now when we've got the Delta variant. What is the best course of action to be taken? I see some people also mentioning increasing cases of children with COVID in the US, with particularly because of the Delta variant. What is the current verdict on that, and where are we in terms of South Africa?
So generally, in a school setting, there is a small risk of acquiring SARS-CoV-2 infection. But it's not particularly higher than if you were not at school. Okay? The big issue with schooling is that the outbreaks we have seen in school start from exogenous spread. So in other words, often it's a teacher that gets infected, brings it into the school, and it infects the other teachers mainly. They say if you really want to stop the spread of the virus in school, close the staff room, because that's where people are going to eat their lunches, they don't wear masks, and so that poses a threat. The transmission from adults, that is the teachers to the children, is low. That risk is low, and we actually measured it in Gauteng in the first wave. It's strikingly how low it is. The risk of spread from the children to teachers is also low. Now, there are two studies, one in Germany and one in Australia, that measured this from teachers and children who were positive and tracked how the virus spreads. There is very limited spread, even if the classrooms don't maintain the 1.5 meter distance that we recommend. Even without that distancing, we really don't see that much spread in children. The one issue is that when you are in the peak of the epidemic, schools become more important at that time, because there is such a high risk that in a class of 40 children, that there'll be 1 or 2 infected. And so the immediate children around them are at higher risk. So that's the reason why schools become important as a site of transmission, is when we're going into peak. When we're not at peak, schools play very little role.
Thanks, Sim. Alex, any further add-ons to that answer?
Yeah, I think the one more thing that I wanted to ask about the vaccine that I didn't mention earlier when we were kind of going through the basics of the vaccine, just before I forget it, is I've seen a few in the chat, and then also it was brought up by Talita, one of our RX Radio Young reporters, is how many times do you need to get the COVID-19 vaccine? Once you've had it, will you never have to have it again in your life? Or is it something that, like the flu vaccine, might have to be taken yearly as we see these variants developing, particularly now the Delta variant, which may appear to affect children more?
Thanks, Lim. And before you answer that, just 1 second, trying to be democratic. Professor, disabilities versus COVID infection. I really love you to answer. We know so many children who have cerebral palsy. Any comment on that specific question? And then just one other specific question, if I can find it, because it relates to Alex and you, regarding children with primary immune deficiencies who are on immunoglobulin replacement therapy. Do they have some protection against serious illness from their treatment? If I can just throw those two in as well.
Okay, so some of your questions don't have short answers. So yeah, I'll just give a summary answer, and they'll have to attend one of my talks to get a more detailed answer. So let me just deal with Alex's question, because there's no easy answer to that question. Let's just say the following. What we know is that if you've taken the vaccines we are currently using, the 2 vaccines we're currently using and any of the other vaccines, the memory B cells and the memory T cells are present, and they look to be in reasonable numbers in those who've been vaccinated. Right? So that's just a background scientific fact. Now, the reason for getting a further vaccination beyond the 2 doses of Pfizer or the single dose of Johnson & Johnson is for one of 2 reasons. The one is called waning immunity. That means the immunity you got from the vaccine, it's now disappearing. The second is not waning immunity, but what's happened is that the virus has mutated and changed, so that the immunity you got against the old vaccines, they don't recognize, those antibodies don't recognize the new versions of the virus. So we have to give you a booster shot to broaden the immune response, not because it's waning, but just to broaden it. So there's 2 different reasons why we need boosters. On the issue of waning immunity, the scientific community is at odds. There are strong opinions on either side. And if you take the 2 big companies, Moderna and Pfizer, both of them have argued that we need to give booster shots. I won't explain to you why a private company would want to sell more vaccines to give, booster shots, but the FDA has not supported that, and most of us in the scientific community don't support that at this point. And also, there's no clinical evidence that if you take a booster shot, whether you're better protected than somebody who doesn't have a booster shot. And the booster shot anyway is a temporary benefit. As I told you about hybrid immunity, if you take a booster shot, doesn't help because you've already got the amount of memory you can get. So not an easy answer, but I've given you snippets of that answer. Right now, booster shots are not recommended. I personally am of the view that people who are immunocompromised should get booster shots, or at least have an antibody test, but they should get booster shots because immunocompromised people don't respond well. So these are people on uncontrolled HIV, or they have lymphomas, or they're taking transplant medication and so on. Those individuals will probably need a booster shot. That's a personal opinion. It is not policy in our country at this point, but I suspect it's going to become policy soon. Now, let me answer your other two questions quickly. Can't remember what they were now, Mark.
Children with disabilities, cerebral palsy in particular was mentioned.
So the vaccine is safe in children with cerebral palsy. It's, in fact, when we were doing the Sisonke rollout, we vaccinated several children with cerebral palsy, no problem. And we've not seen any adverse effects of the vaccine in children with those kinds of disabilities. So children with any of those disabilities, no problem.
Thank you. And then the other was children who are on immunoglobulin replacement therapy. Do they have some protection against serious illness from their treatment?
Right. That's not an easy question to answer, and doesn't have a single answer.
Okay. Melanie, that you heard that, and I won't push Slim to give a simple answer if there isn't a simple answer. And then, sadly, we're almost out of time. While you're thinking, both of you, about any concluding comments, there was a question again from another young person. I can't find her now. I wanted to give her name, Jane or June. June, who's 9 years old, would like to know if people who have been vaccinated must still wear masks. And then there was, I think, quite a number of people have asked questions about anxiety and mental health related issues. There was a young person who put up a question saying that they are isolating at the moment. I think he or she was 10 or 11 and worried about mental health issues, his own mental health issues. And any comment quickly, Slim, on both of those?
Sure, I can quickly deal with the first question. Now remind me, the first question was
vaccination and masks.
Masks, yeah. So the answer to that question is yes, wear mask, wear mask. Don't follow, not so good advice as we're seeing in the US right now. The reason for that is that there are new mutations of the virus occurring in what are called variants of the virus. So the virus is changing. And so the vaccines don't provide full protection. And no vaccine is 100% effective. So you should continue wearing a mask. It's good practice. It also has a broader benefit, not just to you, but to the broader community as well. So yes, wear a mask. The second question about, I'm forgetting now. Can't remember short term.
Just mental health and anxieties in children.
I have to say that there's now several reports, and there was a Lancet report on this as well, on mental health in relation to COVID. And I mean, mental health has taken a huge knock. What we have to do in many ways is develop resilience. In many ways, the quarantine, the isolation that we're dealing with, they're all about how well we develop our coping mechanisms and how do we do that, whether we do it with friends, whether we do it with digital technology, whether we do it by finding ways to entertain ourselves. So all of those become important. So all I can recommend to you is, you want to try and develop your coping mechanisms as part and parcel of your quarantine or your isolation.
Thank you so much, Professor Abdool-Karim. We've hit 7 o'clock. I'll ask the 613 people who are still with us to give us another 3 minutes. Alex, people have been very impressed with your contributions. this evening. I'm afraid the time for your questions has run out, but do you have any parting reflections that you would like to make as a young person on this issue? And then, Salim, I'll ask you the same question as an older person.
Yeah, I think for me, it's definitely made a couple of things a bit clearer, particularly how vaccines work. I got excited in biology at school, life sciences. We do learn about mRNA, so I got excited when I recognized that. But obviously, it is something I've heard over the past year and a bit. But thank you so much to both of you for having RX Radio involved with this, and to everyone who has come on and supported it. Thank you so much. I'll just close by saying this is something that RX Radio is all about, is spreading health information, and particularly providing a platform for the youth to have their questions voiced, to have their concerns voiced. And looking through the chat, I see that it is something that people believe is a very real issue. And if you want to find out more about RX Radio, if you want to support RX Radio, since it is a non-profit run entirely on donations, you can check us out at rxradio.co.za. There's a lot more content there. People have been asking for more information, content, etc. You can find out everything RX Radio does and check out all our young reporters and the content that we host over there. Thanks so much.
Thank you so much, Alex. Professor Abdool-Karim.
Well, Mark, it's just a great pleasure for me to be on this program and to have the opportunity of being quizzed by Alex. And I hope I've given you some sense of this virus, some sense of this disease, and some of the challenges we face. We don't know all the answers, and some of our answers are tentative, and that's part of the challenge with COVID-19, that some of our knowledge and our information is tentative, and it changes with time. And so what we are learning is that science is part and parcel of understanding this virus, but the way we respond is beyond science. It's with our humanity, it's with our ethics, it's with our principles, it's with, to me, the most important is that it must bring in each of us our understanding of our interdependence, that I am not safe until everyone is safe. No country is safe until every country is safe. So we are in this together, all of us, and we're going to solve it together.
Thank you, Professor Abdool-Karim. Thank you, Alex. Thank you to all the audience who've been with us tonight for very, very important and meaningful and focused questions. I'm so sorry we haven't answered about 80% of them. I'll try and persuade my bosses at the Daily Maverick that we need another young person's webinar, because many of you have approved of hearing young people as they should be heard. But obviously we also need more webinars talking about basic science and facts and responses to COVID-19, which is very much still with us. Thank you to Nicole Williamson, who's behind the scenes person who is incredibly professional and puts all of this together. Just to say, put in your diaries, on the 24th of August, Slim will be back here again, but next time with Edwin Cameron, Justice Edwin Cameron, formerly of the Constitutional Court, to talk about COVID-19 and vaccination and human rights. And there are a bunch of very important questions there, so diarize that as well. Thank you, everybody. Thanks to all the healthcare workers who are with us and not with us, and stay safe in the course of this pandemic. Good night. Thank you.